Welcome to the CSEC Physics Masters YouTube channel, the channel that will teach you everything you need to know about CSEC physics. Please remember to like, share and subscribe, as there are numerous topics that we will go through in detail to ensure that you master this subject. The topic that we'll be looking at today is unit conversion, and it is a very important topic because it is one of the pillars of understanding physics. Unit conversion is one of the three pillars that one must comprehend in order to attain mastery of physics. In other words, in order for candidates to master the fundamentals of this subject, they must be able to convert units. And mastering unit conversion comes with understanding the prefix table. As you can see, this particular prefix table goes from tera to pico. The multiples are in blue, while the submultiples are in green. Each prefix is represented by its own symbol, and each prefix is also represented by an integer value. One must also make a note of the fact that there is no prefix for the integer value 10 to the 0, for this is where the meter will fall if considering length, or where the gram will fall if considering mass. In terms of storage capacity, we may be more familiar with kilobyte, megabyte, and gigabyte, but the byte, which is the base unit for all of them, will fall at 10 to the 0. We must also recall that anything that is raised to the power of 0 is equal to 1. In essence, 10 to the 0 equals 1. When performing calculations in physics, the units must be able to cancel each other, and in order for this to occur, they have to be represented in the same form. This is what we call the homogeneity of the units. For example, a gram cannot cancel a kilogram, even though both of them are units used to represent mass. Pay keen attention to the calculation that is demonstrated below as we try to augment and cement the understanding of what we are driving at. An object of mass 500 grams exerts a force of 3 newtons. What is the acceleration of this object? We start by listing the numerical values. We see them better when they are taken out of the words. So, in essence, F is equal to 3 newtons, A is the unknown, and M is equal to 500 grams. The G should be converted to kilograms, but we are going to leave it as it is in order to demonstrate the problems that will arise if we fail to convert to SI units. The formula that we are dealing with is F is equal to ma. Force is equal to mass times acceleration. So we write that formula. After which we need to transpose the equation to make what we want to find the subject. In this case, we need to find the acceleration. So the formula will ultimately become A equals F over m. Then we are going to substitute the numerical values into the equation. So we are going to substitute for force and write 3 newtons, and substitute for mass and write 500 grams. Since n is also equal to kilogram meters per second squared, we will also substitute for n. The resulting equation that will evolve from this is 3 kilograms meters per second squared divided by 500 grams, and that will be equal to A. The masses should cancel each other out in order to retrieve the acceleration in its correct SI unit form, which is the meters per second squared. But because the one above is in kilogram and the one below is in grams, this is not possible, for they exist in two different forms. In essence, grams cannot cancel kilograms. Hence, proceeding with this calculation will ultimately result in an incorrect answer. The units cancelling each other out, leaving the SI unit of the quantity that you want to find, is an indicator that you are on the right track. But if these units cannot cancel each other out, it shows that they lack homogeneity, and the answer, the numerical value, will be wrong. Many individuals find physics difficult and confusing because they do not know when to convert the units and when not to. So my advice to you is to convert all units to their SI unit form before substituting them into any equation. And even though some questions can be accurately calculated without converting to SI units, most of them cannot. So in order to be on the safe side, it is strongly recommended that all units be converted to their SI unit form before substituting them into equations. Doing this will emphasize the homogeneity of the units, since they will all be in a standard form, which will allow them to cancel each other, and will thus always lead to a correct answer by eradicating the indecision of when to convert and when not to. Taking a look at a particular example of converting 9.0 micrograms to kilograms. When converting units, there are several steps that must be followed in order to ensure accurate results. 1. The most important of these steps is to study and master the contents of the table. This strategy will allow you to convert from anywhere to anywhere, but in order to use it, you must know the table. Use a pencil to mark on the table by putting a 1 where you are asked to convert from, and an arrow where you are asked to convert to. Marking the points where you are coming from and where you are going to is very important. 3. Starting from the 1, move to the adjacent prefix that brings you closer to the arrow. At this point in time, you need to pay keen attention to the integer values, for you will need to add a 0 for each exponent place value that you cover. For example, if you move from 10 to the negative 2 to 10 to the negative 1, you must add 1 0. But if you move from 10 to the 9th to 10 to the 6th, you will need to add 3 zeros. Going up or down or from negative to positive does not matter. All you need to know is that you add 1 0 whenever you move one exponent value and 3 zeros whenever you move 3 exponent values. Continue performing what is stated in step 3 in a sequential manner until you reach the arrow. The arrow marks where you are supposed to stop. Write down the number that you get, which is in this case 1 billion. Redirect your attention to the written question to see if you are being asked to convert from a larger unit to a smaller one or vice versa. In the question above, you are being asked to convert from micrograms to kilograms, and since the micro is smaller than the kilo, you are moving up the table. Whenever you move up the table, converting from a smaller unit to one that is bigger, you divide. And whenever you move down the table, converting from a larger unit to one that is smaller, you multiply. Which basically means that for this particular example, you are going to divide the 9.0 micrograms by that long number you wrote down in step 4. That is the 1 billion. This will yield a final answer of 0.000000009 kilograms. Take a look at this particular exercise, 3 of which has already been done. Please do numbers 4 to 10 and display your answers in the comment section below. And if you have not already subscribed, please subscribe to this channel because there are numerous topics that we will be going through. And also remember to like and share this video with everyone you know, especially those persons who are struggling with CSEC physics.
Okay, now, let's say you're asked to convert from 8 megagrams into micrograms. The first thing you need to do is to make a quick sketch of your prefix table, as shown. As you can see, it goes from tera to pico, and only the symbols have been written, along with their numerical value. Now, because you're moving from megagrams and moving right down to micrograms, you're going to put a 1 beside mega, like that. And then you're going to look for micro. Go down and look for micro and put an arrow beside micro. Just like that. So in essence, you need to move between mega and micro. Now, take a keen look at the exponent values. You notice mega is 10 to the 6. Next in line is kilo, which is 10 to the third. Now remember, whenever you're moving 3 places, you add 3 zeros. So from 6 to 3, 1, 2, 3 zeros. From 3 to 2, only 1 0, because that is only one place. From 2 to 1, 1 0, 1 to 0, 1 0, 0 to 1, add another 0, 1 to 2, another 0, 2 to 3, 1 more 0, and 3 to 6, 3 places, you add 3 zeros. The negative signs do not matter. Just remember that when you're moving from 6 to 3 or from 3 to 6, either way you add 3 zeros. And if you're only moving one place, you add 1 0. Now, what this shows you is the number of micrograms within 1 megagram. And if you check off the zeros, 3, 6, 9, 12. That is 1 trillion. So in essence, 1 trillion micro makes up a mega. After you find this number, you go back to your question. And you're being asked to convert from megagrams to micrograms, which means that you're being asked to convert from something that is larger into something that is smaller. The fact that you're being asked to convert from larger to smaller, you are going to multiply, because whenever you're going down, you always multiply. If you're going up from smaller to larger, you would have divided. So the fact that mega is bigger than micro, it means that you're moving from something that is larger to something that is smaller. And as a result of this, you have to multiply. So you're going to take this number that you just found from your table and multiply it by the value that is there in front of your mega. In which case, it is going to give you 8 and 3, 6, 9, 12 zeros behind it, because the point is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I need more space. 12. And the point is now there. So 8 megagrams is the same thing as 1,000, million, billion, trillion. 8 trillion micrograms, as you can see. So, in essence, this is how we use the table in order to convert. Take a good look. Looking at another example, we will do the same. But this time, we are moving from 16 nanometers, and we want to convert that into kilometers. So example number 2. Now, as I've said before, you have to work with your prefix table. And this table will allow you to convert from anywhere to anywhere. But you must know the table and to know the value for each of the prefixes. So we are moving from nano and we'll go into kilo. In this case, we are doing length. Of course, first you have to write a 1 beside where you're coming from, which is the nanometers. And then you're going to put an arrow where you're going. This arrow is important because you do not want to fly past where you are trying to go. And it happens, it does happen, because when you master it and you start to move very quickly, you normally fly past where you want to stop. So, that is why the arrow is vital. And looking at the value for nano, it says that it is 10 to the negative 9th. The next thing in line, going up, we are going up. The next thing in line is the micro, and that is 10 to the negative 6. Remember, I said the negative sign does not matter whether you're moving within the negative values or within the positive values. That does not matter. All you need to know is that whenever you're moving from like 9 to 6, that is 3 places, you add 3 zeros. And whenever you move 1 place, you add only 1. So 9 to 6, 3 places, 1, 2, 3 zeros. 6 to 3, that's another 3 places. 1, 2, 3 zeros. 3 to 2, what comes after 3 when you're counting down? It's 2. So that's the next place. You only add 1 zero. 2 to 1, 1 0, 1 to 0, 1 0, 0 to 1, 1 0, 1 to 2, 1 0, and 2 to 3, 1 0. Counting them off, 1,000, million, billion, trillion. So we have gotten another trillion. But in this case, we're moving from something that is smaller into something that is larger. So we're going up the table. And the fact that we're moving up, it tells us that we need to divide. Whenever you're moving up, you divide. So you're going to take this number that you just found from your table and you're going to divide it into, or you're going to divide this 60 here by that long number that you just found. In which case the point is here. People, you do not need calculators. The point is there. Now, the number of zeros within this figure here tells you how many times the point should jump. You are dividing, so that tells you that the point should go to the left. Whenever you're multiplying, the point travels to the right. So you have a 12 zero value there, 1 trillion. The point is going to jump 12 times to the left. So it is going to jump 1 time over this 0, 1 time over the 6, and 10 more times. So you're going to first add a place value 0, behind which you put the point, and the point will jump 12 times. 1 time over this 0, 1 time over the 6, and 10 more times. So you're going to put 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you put your 6. And just for argument's sake, I am going to put this 0 just to show you something. So the point was there. You are dividing by 1 trillion, so the point is going to jump 12 times because you have 12 zeros within a trillion. 12 zeros within a trillion. So the point is going to jump 12 times. Whenever you're dividing, the point goes to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The point jumped 12 times. However, this 0 that is behind the 6 becomes insignificant. And as a result, you can erase it. So in essence, 60 nanometers is the same thing as 0.00000000006 kilometers. Take a good look at the example.